All right, thanks for joining for the second part of section 4.2. What we're covering here is the rest of the unit circle, and then just some other tidbits that are going to be a little bit important or super important. So first, we want to start with the three other trig functions. In the first half, what we talked about was sine, cosine, tangent, but we also have cosecant, secant, and cotangent. These are known as reciprocal trig functions because all they are is 1 over sine, 1 over cosine, and 1 over cotangent. So they're the reciprocal of sine, cosine, and tangent. Make sure that you know what those are equal to. The fact that cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Quadrants 2, 3, and 4 have essentially the same coordinates as quadrant 1. So we covered quadrant 1 of the unit circle. But the only thing that's going to change when I go from quadrants 1 to 2 to 3 to 4 is positives and negatives. So if I was looking at quadrant 1, we know that this is a positive, x and y. In quadrant 2, what I'm doing is making my x values negative, but my y values stay positive. In quadrant 3, both of these would be negative. And in quadrant 4, I would have a positive x value, but a negative y value. And that's going to happen with all of our coordinates. The coordinates, like the actual numbers, are going to stay the same for those coordinates, but they're going to change signs. So looking at this, in quadrant 1, all things are positive. In quadrant 2, sine is positive because sine represents our y values, and in quadrant 2, y is positive. Cosine and tangent are negative. Quadrant 3, so we're looking here in quadrant 3, cosine and sine are both negative. Tangent is the ratio of those, so tangent is positive. And sine and cosine are negative. And then last in quadrant 4, cosine is positive because x is positive. And sine and tangent are negative. A way of trying to remember the order in which this goes is all students take calculus. Whether or not that's true, I guess we'll see, but all students take calculus. A, S, T, C. That tells you the quadrants in which things are positive. So quadrant 1, all things. Quadrant 2, S, sine. Quadrant 3, T, tangent. And quadrant 4, C, for cosine. Keep that in mind as we move throughout. It's just a sort of way of trying to remember. You can also just remember like quadrant 1, quadrant 2, quadrant 3, and quadrant 4, what those signs look like. Keep in mind cosecant, secant, and cotangent, since they are just reciprocals, they would take the same signs as anything that's in here. So like in quadrant 3, if tangent is positive, cotangent would also have to be positive. It would just be flipped over. All right, so if we're talking about the coordinates in the other quadrants, we're going to do quadrant 2 first. If I'm talking about quadrant 2, in red, I'm just going to do our degrees. So this was 90 degrees. Continuing on, then what I do is add 30 degrees to this. I have 120, and then it's increments of 15, 135, 150, and last 180. Notice it goes 30, 15, 15, 30. So these are my degrees that I have to know. The next thing I have to know is radians, pi halves. What 120 degrees is two 60-degree angles and two 60-degree angles. Well, 60 degrees was pi thirds, so this is 2 pi thirds. 135 degrees was, I missed it, 3 pi fourths. 150 degrees, I'm just going to work this way, is going to be 5 pi sixths. And 180 degrees is just pi. So then we get to the coordinates for each one of these. 90 degrees, we said that coordinate was 0, 1. For 120 degrees, what you're doing is taking the coordinate that was right over here. That coordinate was 1/2, comma, root 3 over 2. So when I'm talking about that coordinate 1/2 root 3 over 2, all that's happening is now it's flipping over this y-axis. So it's making that x value negative. So this would be negative 1/2 root 3 over 2. The coordinate over here, which was root 2 over 2, comma, root 2 over 2, is flipping over, so x becomes negative. So negative root 2 over 2, comma, root 2 over 2. Again, keeping in mind the x values are negative here, the y values are positive. Last, we'll have that root 3 over 2, comma, 1/2, and this one was negative. And with pi, negative 1, 0. Remember that this is a unit circle, meaning our radius was 1. So these are all those coordinates, and again, all that is just reflections. What I'm pulling up now is going to be our tangents. So here we said our tangent was undefined. Our tangent here was the one that was square root 3. Tangent is negative in this quadrant, so I'll have negative square root 3. Here I had a tangent of 1. This will be negative 1. Remember, tangent is the ratio of these, y over x. Here I'll have negative root 3 over 3 and 0. So that is your quadrant 2. If you now, I can't exactly demonstrate this here, but if you were to go from your quadrant 2 and look at quadrant 1, you would realize that there is perfect symmetry of all of these coordinates. They're flipping straight over. And all that's changing is the negatives for tangent and cosine. What's in blue and red, the angles, those obviously don't have that same exact symmetry. Although you will notice over here is when you had over 3, you had pi thirds. So over here is when you had pi thirds. Over here you had pi 6. So over here you have that over 6. We will do one giant unit circle together, and you'll be able to sort of see that symmetry as well. So now going into the, there we go, third quadrant. So third quadrant, what I'm going to start with is just all of our angles. We said that this was 180. I'm not going to rewrite it, but this is 210, 225, 240, and 270. Our radians then, this is always the one that's over 6, the one that's closest here. So this is 7 pi 6ths. It's just past pi. This is 5 pi 4ths. It's just past pi. This is 4 pi thirds, which again is just past pi in terms of thirds. And then here I have my 3 pi halves. For my coordinates, if you're thinking about this previous one, so all we're doing is taking these pink coordinates, and now we're reflecting it downwards over the x-axis. So this coordinate is still going to be just right here, very close to this 180, but now x and y are going to both be negative. So I'll have this coordinate being negative root 3 over 2, comma, negative 1/2. Here, again, bringing that next coordinate down, I have negative root 2 over 2, comma, negative root 2 over 2. Here I have negative 1/2, comma, negative root 3 over 2. And again, up here I had 0, 1, which is now going to become 0, negative 1. So these are all things that you have to memorize, or you can try and come up very, very quickly with how the first quadrant is going to relate to them. Looking at our tangents, we said all students take calculus. So take third quadrant. Tangents are going to be positive. So here I'd have 1. Usually start with this one because it's easy. You know, the ratio of this. Here, you need the smaller tangent, root 3 over 3. Here you need your larger tangent, root 3. And here tangent is undefined. So there you have all of quadrant 3. Moving on, then we have, yes, quadrant 4. And you're going to see, again, it's like the same numbers in the same orders, and all you're doing is changing your positives and negatives. So I'm going to start first with the degrees. This was our 270. So this is 300, 315, 330, and 360. This one is the same as that 0, coming full circle from what we did in quadrant 1. Next are radians. Well, this is the one that's close to the y-axis, and that's always the one that's over 3. So I know this is something thirds. This was 4 pi thirds, so this is 5 pi thirds. This is the one in the middle, which is always over 4. Over here I had 5 pi fourths. This is not 6 pi fourths, because that would be 3 halves. So this is 7 pi fourths. Over here, the one close to the x-axis is always over 6. Over here, I had 7 pi sixths. 8 sixths would be 4 thirds. 9 sixths would be 3 halves. 10 sixths would be 5 thirds. So this is 11 sixths. It's also just shy of a full 2 pi. If you think about this being 2 pi, which is 12 sixths, I just missed it. So 11 sixths. And then those coordinates. All we're doing is taking these pink coordinates. Or if you went back to quadrant 1, you could talk about those ones as well. And what we're doing now is flipping them over to the right. And doing that, I'm making my x values positives. So over here, I'm going to have root 3 over 2 comma negative 1/2. X is positive, y is negative. Here I'd have root 2 over 2 comma negative root 2 over 2. And 1/2 negative root 3 over 2. I'm not doing the 0, 360 because you already have that in the quadrant 1, and I know you don't want me spending more time than is needed. Then with my tangents, all students take calculus. So cosine is the only thing that's supposed to be positive here. Makes sense because I have my x values, which are cosines, positive. So tangents, 1, the smaller one, the larger one. And there you have quadrant 4. Notice that all of this is just going to be sort of reflections. The degrees and the radians you have to get sort of memorized and comfortable with. But otherwise, these coordinates, if you know the first quadrant, it's just reflecting it over to the second, third, or fourth quadrant. All right, so remember that the way that we define angles is that they can be bigger than 360 degrees or 2 pi. So because of that, we say that trig functions are periodic. And what that means is that they repeat themselves as you go around the circle again. So for instance, if I was talking about pi sixths, this is the angle pi sixths. But if I went all the way around and stopped at that, if it was coterminal, they are going to have the exact same coordinate. They are different angles, but they will have the same coordinate, meaning they have the same cosine, sine, and tangent. And that's why we talk about that coterminal stuff in 4.1, is so that you get down the idea that the angle can be different, but your cosine, sine, and tangent, they're going to come out the same still. So a function is periodic if there exists a number c such that f of t plus c is equal to f of t. And all this is really saying is that if I could add something to my input and get the exact same function value as if that c was not really there, then it's periodic. So like here, f of pi sixths is going to be the same as f of pi sixths plus 2 pi. Because here I have pi sixths, and all the way around here I have f of 2 pi sixths. And if I was asking for like the sine, the sign would be the same at either one of these coordinates, meaning it's periodic. That has to be for all t in the domain of f. So no domain restrictions. The least number c for which f is periodic is called the period of f. So if a function is periodic, there is a period to it, which is the smallest thing that I could be adding to the function to get the exact same values. And we'll deal sort of more with that later on when we write and solve trig equations. But just keep that in mind. Functions are periodic. Trig functions a lot of times are periodic. And they have a period, which is the shortest thing or smallest thing that I could be adding until this is going to start repeating. And then last, what we're going to talk about is just even odd functions. So when we talk about even and odd functions, sine and tangent are considered odd and cosine is considered even. Talking about the fact that something is odd means that you have symmetry over the origin. Something that's even is symmetry over the y-axis. And we talked about even and odd functions earlier in the year, probably like chapter 1. But now we're just coming back to this. So sine and tangent are odd. The way that that's going to look and what it's going to allow us to do is say that the sine of a negative angle. So the sine of a negative angle is always going to be equal to negative sine of the positive angle. So something like the sine of negative 30 degrees, that's going to be the same thing as the negative of sine of 30 degrees. Cosecant, since it is a sine function, it's just the reciprocal of sine, will have that same property. Cosecant of negative theta is negative cosecant of positive theta. I'll jump down here. Tangent is also odd. So tangent of negative theta is negative tangent of positive theta. Cotangent, since it is a tangent function, cotangent of negative theta is negative cotangent of theta. Your even functions work differently. So the cosine of negative theta is going to be the same as your cosine of positive theta. Your secant of negative theta is going to be the same as their secant of positive theta. And a really cool thing for you to do is, like, once we draw out a whole unit circle, is just look at this and test it. Or if you're good at picturing it, think about it now. If you think about like the cosine of negative pi sixths, it's going to be the exact same thing as the cosine of positive pi sixths. If you talk about the sine of negative pi fourths, it's going to be the same as the sine of pi fourths with a negative in front of it. So, if you want, go experiment with that. Otherwise, stay tuned until we draw out a whole unit circle and then try and piece that together. But either way, get started on section 4.2. Keep in mind, those quadrants are all stuff that you have to know. You have to get it down. I don't really care how you memorize it. Some people try and memorize all of those points. Not the best strategy. I would say memorize that first quadrant and then just be able to think through, how do I get to the stuff in the second, third, and fourth quadrant? Otherwise, bring in any questions that you have on any of these notes.